Guys, and welcome to my YouTube channel. We are going to start preparing for CAPF AC exam 2026, and we are starting with the physical geography section. Our main focus should be on conceptual clarity and PYQ based discussion. So starting with the chapter 1 of the physical geography, that is geography as a discipline. Now this is the most ignored chapter, but we have to look upon some important points from here also. That term geography, it has been coined by Eratosthenes. Eratosthenes, a Greek geographer. Now, what does it mean? It is derived from two words, geo plus graphos. Geo means earth, and graphos means description. So, geography is the description of the earth, and human being is a integral part of the earth. So, geography is now defined as a description of earth as the home of human beings. Now there are some set of questions that geography is concerned with. First one is what? That what are the patterns of natural features found over the surface of earth? Second is where? That where are these features located? And third one is why, which is examining the reason behind the patterns of these physical features. And fourth one is very important, that is time. How does these features changes over time? Now, to study geography, geography has been divided into various sub branches. Like, first branch is systematic geography. Systematic geography, which is being developed by Alexander von Humboldt. Alexander von Humboldt. And second one is regional geography. Regional geography, which is developed by Carl Ritter. So, systematic geography basically focuses on studying the phenomena and developing the theories and hypotheses that are generalized for all over the areas like physical geography. It includes physical geography, and it is further divided into geomorphology, hydrology, soil geography, also human geography, which is further divided into social, population, settlement, economic, and various others. And regional geography, studying all this subsection of geography related to a specific area. Like studying the monsoon as a phenomena comes under the systematic geography, and study of a region like Deccan Plateau or Peninsular India, studying all the geographical features of these regions come under the regional geography. Now moving on to the next chapter, that is about origin of Earth and universe. So there are various theories about the origin of Earth. So reading the earlier theories, first one being the nebular hypothesis given by Immanuel Kant. Immanuel Kant, and it is later revised by Laplace. Revised by Laplace in 1796. It considers that planets are formed by a nebula, that is cloud of slowly rotating gases around the sun. Now next one is planetesimal theories. Planetesimal. theory, which is given by Chamberlain and Moulton. Chamberlain and Moulton in 1900. It states that a star approached the sun, and due to the gravitational pull of that star, the sun developed a bulge in its surface, which is like cigar shaped. And now later, that bulge was pulled out of the surface of the sun, and the planets are formed. Now the next theory is binary theory, which is given by James Jeans and Sir Harold Jeffrey. James Jeans and Sir Harold Jeffrey. It considers that there is a companion of sun. Sun is not alone. There is another system of two suns, and the star passes by them, and then the planets are formed and start rotating around the sun. Now, moving on to the modern theories, the most prominent being the Big Bang theory. Big Bang theory, which is given by Edwin Hubble. Edwin Hubble in early 1920s. This theory is also known as expanding universe theory. Expanding universe theory. So it considers that earlier the universe was a singular point, and it has small volume, infinite temperature, and density. And then suddenly it explodes violently around 13.7 billion years ago. And it is also expanding till date, and the atoms formed due to this collision, explosion. And after around 3 lakh years, the temperature start dropping. Temperature dropped to around 4500 Kelvin, due to which the condensation starts and the planet start getting its shape. There is also another theory which is known as Yole's concept of steady state, which is antithetical to this Big Bang theory, which says that universe is not expanding but it is in steady state. But this is majorly rejected by many geographers. Now these theories are asked in the CDS 1 2026 exam. So do not ignore them. They can also be asked in the CAPF exam also. Now moving on to the formation of stars. So s- star formation. So star formation took place around 5 to 6 billion years ago. So as the explosion happens, there are different atoms and having different densities. So this density difference causes the differences in the gravitational forces, due to which the matters are drawn together in form of galaxies. What are galaxies? These are the clumps of gases in form of nebula. And in this nebula, as the dust particle are rotating and they are getting and the temperature is dropping, so these particles started getting condensed, and the small particles are condensed in form of stars. So this is how the star formation took place. Now moving on to the formation of planets. So the formation of the planets is also same, but it took place at the later time, that is around 4.6 billion years ago. 4.6 billion years ago. These small condensed particles start getting to combine with each other, and a large particle is formed that is known as planets. Now the solar system, let us look at our solar system. Solar system, it includes sun, planets, there are 8 planets, moons, around 891 moons. Among these, Saturn has maximum number of moons, and Mars and Venus, sorry, Mercury and Venus does not have any moons. And also asteroids and comets, dust particle, are also part of solar system. Now the planets, these are being divided into two parts, that are terrestrial, Earth-like, and Jovian, that is Jupiter-like. These are smaller in size, these are larger in size. These are terrestrial, these are gaseous. They have higher density, less dense. These are inner planets, inner planet, and these are outer planet. Outer. Now terrestrial includes Mercury, Venus, Earth, and Mars. And outer planet includes Jupiter, Saturn, Uranus, and Neptune. Now the density of Earth is maximum here, which is around 5.517 gram per centimeter cube. And the least dense is Saturn, which is around 0.70 gram per centimeter cube. Now, why is this so? That these planets are smaller in size and denser, and why Jovian planets are gaseous? So, the solar flare is the major cause. That is, the atmosphere of helium and hydrogen is ripped off by solar flares of the inner planets, that are Mercury, Venus, and Earth, Mars. And solar flare weakens when they reaches these planets, so their gaseous atmosphere is intact, due to which they are gaseous in nature. Now, the theory related to the formation of moon, which is known as big splat big splat theory. Earlier it was considered that the moon is formed out of part of a Pacific Ocean, but later this theory, big splat theory, in 1970 was put forward by William Hartmann and Alastair Cameron. William Hartmann and Alastair Cameron, which states that around 4.44 billion years ago, a celestial body around 3 times the mass of Mars, 3 times the size of Mars, collided with Earth, and the Earth blasted into various parts. And one such part of Earth is Moon, which starts revolving around the Earth. Now let us consider the evolution of lithosphere. The steps involved in the formation of lithosphere is, first one is density stratification. Stratification, which is that arrangement of the material according to its density. The denser particle settles at the core, and the less dense particle is arranged towards the surface of the earth. Second is solidification and condensation. As the temperature was dropping with the time, then these hot particles are condensing and solidifying in form of current shape of earth. Third one is big splat. That big splat happens, and thereafter further heating took place, and thereafter this density stratification also took place, and then again solidification, and that is how earth get its lithosphere in the current shape. Now moving on to the evolution of atmosphere. There are three steps in the formation of earth's current atmosphere. First one is loss of primordial atmosphere. Second one is degassing. Third one is photosynthesis. So this primordial atmosphere generally contains of hydrogen and helium, which are stripped off by solar flares. Now, due to the volcanic eruptions and cooling, the gases that are in the interior of Earth outpoured and form the primary atmosphere, which includes water vapor, ammonia, nitrogen, carbon dioxide, methane, and very little free oxygen. Thereafter started emerging the algae and the green plants, after which photosynthesis start taking places, and the current composition of atmosphere, which is largely composed of nitrogen and oxygen, is formed. And this origin of life took place around 3.8 billion years ago. Now moving on to the next chapter, which is about the interior of Earth. Interior of Earth. The radius of Earth is around 6,370 kilometers. So how do we get to know about that what is inside the Earth? So there are two types of sources, that is direct sources and indirect sources. So direct one includes processes like mining, quarrying, deep ocean drillings, deep ocean drillings, and volcanic eruptions. And indirect sources include like change in density of the material of Earth as we move from crust to the core. Density, temperature, pressure, changing all this. Next one is meteors. Meteors are, as they are all composed of the same material, so studying the meteors gives us an insight about the composition of Earth also. This is also indirect source. Next one is gravity anomaly, that is change in the value of G, that is universal gravitational constant. Another one is magnetic fields, that is studying the paleomagnetic curves. The previous magnetic history of the Earth gives also insight about this. magnetic composition. Another one is seismic activity, that is movement of the seismic waves through the earth. How does they move? This also gives us information about the composition of earth. So now let us first look at how does this structure look. It is majorly divided into three parts. First one is crust, second one is mantle, and third one is core. So crust is divided into continental crust and oceanic crust. Continental crust is generally thicker and oceanic crust is thin. But this continental crust is less dense. Its density is around 2.7 gram per centimeter cube, and the density of oceanic crust is around 3. It is generally made up of granite and it is basaltic. And the discontinuity between the continental crust and oceanic crust is known as Conrad discontinuity. Now comes the mantle part, and the discontinuity between the crust and mantle is known as Mohoveric discontinuity. Now, the solid part of the upper mantle and some part of the crust, it is known as lithosphere, and below it there is a part of upper mantle which is semi-solid in nature, which is known as asthenosphere, which is the major source of the volcanic activity on the earth. Now comes the lower mantle, and the discontinuity between the lower mantle and upper mantle is known as rapid discontinuity. Lower mantle, it is also known as pyrosphere. It is also solid in nature. It extends up to the 2900 kilometer. Now comes the core part, which is further divided into outer core and inner core. Now outer core is semi-solid in liquid, which and it contains a lot of ions, and due to churning motion of this, the magnetism of earth is there. So this is also known as barysphere, and the discontinuity between the lower mantle and outer core, it is known as Gutenberg discontinuity, also known as Oldham. Now the boundary of outer core and inner core exists at around 5300 km, and the inner core is solid in nature due to the immense pressure it felt. And the discontinuity between the outer core and inner core, it is known as Lehman discontinuity, also known as Bullen discontinuity. So now let us study about the its sources, which is starting with the earthquake waves. Now the point from where the earthquake originates is known as focus or hypocenter, and the nearest point from the focus on the earth's surface, that is, if this is the focus, and the nearest point corresponding to this focus on the earth's surface, this is known as epicenter. Now the earthquake waves are divided into two parts, that is body waves and surface waves. Now body waves are also divided into two, that is P wave and S wave, primary waves and secondary waves. So these are the first one to originate, and they are formed later, and they are similar to sound waves. They are similar to light. It travels through all the mediums, but secondary wave requires solid medium to travel. These are transverse waves. That is, moment of propagation is parallel to the earthquake waves. That is like this. This is how it moves in form of compression and rarefaction. And the secondary waves, they move in form of longitudinal waves, in form of crust and trough, and they are more destructive in nature. Now let us look at the shadow zones. What is shadow zone? Is an area of the Earth's surface on which no seismic activity is recorded. So for these P waves, the shadow zone, this is the shadow zone which extends from 105 degree to 145 degree, 45 degree. And for the S waves, the shadow zone is larger, which is from 105 degree to 105 degree. Why? Because the S waves need solid medium to travel, and the outer core is semi-solid, so these S waves get reflected and does not pass through the core. Now looking at the measurement of the earthquake, the magnitude is measured on Richter scale, which is a logarithmic scale from 0 to 10 value, and the intensity of the earthquake, that is the damage caused by it. It is measured on the Mercalli scale, whose value ranges from 1 to 12. Now let us look at the volcanism. First, let us look at the properties of magma. So, what does this magma includes? It includes the pyroclastic debris, SO2, CO2, NO2, and a number of gases that you can imagine. This is also a previous year of question. So, now the major content, which is silica, which decides the property of magma. If the silica content is more, then the magma will be more viscous and it will be acidic in nature. And if the silica content is less, then it will be less viscous and basic in nature. It is mafic and felsic. So if the magma is more viscous, then it will be more explosive, and if viscosity is less, then it will be less explosive. Now, the classification of volcanoes. Based on the frequency of eruption, they can be classified into types. Based on the frequency of eruption. Frequency of eruption. They are divided into three parts, that is active, dormant, and dead or extinct. Now, based on the type of eruption, can be divided into two, that is central type, and fissure type. These are basically found on the convergent plate boundaries. Similarly, they are found on the divergent plate boundaries. These are more explosive, silent, and they lead to the formation of high relief features like mountain peaks, and they lead to the formation of low relief features like plateaus, oceanic ridges, and they are spread over low areas, spread to lower areas, and they are spread to a larger area. And the explosivity of volcanoes, that is intensity of eruption, is measured on the volcanic explosivity index, VEI, which is a scale from ranging from 1 to 8, 1 being the least explosive and 8 being the most explosive. Now, based on their shape, they are also divided into shield volcano types like shield volcanoes. They are the largest volcanoes on the earth. They are largest, very fluid. Fluid means less viscous. Less viscous means basic silica content will be low, characterized by low explosivity. Second one is composite, more viscous, high explosivity, and form features like this mountain. These are the composite volcanoes. Now, caldera, they are the most explosive one. As they are as explosive, when they collapse, they tend they collapse. When they explode, they collapse. This is the intensity of the explosion in caldera. Now comes the flood basalt provinces. Deccan Plateau is the example of this. So these are very fluid, less viscous, same characteristic of the shield volcanoes. Now let us look at the volcanic landforms. Landforms. So the lava can solidify inside the earth or on the surface also. So when the cooling happens inside the earth, inside it is known as plutonic rocks, and on the surface it will be known as volcanic rocks. Volcanic. And remember that if the cooling of magma will be rapid, then the rock form will be crystalline igneous rock. That will be relatively soft and more weathering will happen in these. And if the cooling will slow, then non-crystalline hard rock will form. Non-crystalline hard rocks. And if the cooling will be very rapid, then glassy igneous rocks will form. Glassy igneous rocks. For example, obsidian is an example of this. Now the landform are classified into two types, that is intrusive and extrusive. Intrusive landform includes batholith, lacolith, lapolith, sill, dikes, sheets, pacholith. So the batholith is the larger deposit inside the Earth's surface. It is also act as secondary magma chamber. Lacolith, lacolith is the inverted U-type structure. Lapolith is like saucer shaped. Stills are horizontal, horizontally solidified magma. They are also known as sheets. And dikes are vertically solidified magma in the vents. And phacolith is in form of this anticline and syncline. This is known as phacolith. Now, extrusive landform. These include shield or dome, or cinder cone, or the composite or stratified cones like this. This is the central vent, and the magma outpours from here. Is collected. This is a composite cone. In this layered arrangement of rocks is found. Now, parasitic cone. This is central vent. This is a composite structure, and when the this volcano is in extinction state and the lava does not flow up to the uppermost region, then it start going through these spaces and form the parasitic cone on the sides of this composite structure. So it is in the stage of dormancy, parasitic cone. Now moving on to the next chapter, which is discussing about the distribution of oceans and continents. Now in this we will look about the configuration of the earth surface, that is position of the continents in the ocean. So as there are 7 continents today, these are not the same in the past. This was first considered by a Dutch cartographer whose name was Abraham Ortelis. He was the first one to state that these continents were part of a one landmass and they are separated later. Now, this was solidified in form of theory by Alfred Wegener. Alfred Wegener in form of continental drift theory in 1912. So he stated that the landmass was earlier in two forms, that is Pangaea and Panthalassa. Pangaea and Panthalassa. Pangaea was a supercontinent and Panthalassa was a super ocean. And for breaking of this Pangaea into several continents, he stated that the force behind this is polar fleeing force and tidal forces. Tidal forces. So, which are being later questioned by many scientists that these are not sufficient to move the continents, which is also correct. Now, he provided a set of evidences in support of the continental drift theory. First one being the jigsaw fit of the continental boundaries of the continents. Second one is rock radiometric dating. By radiometric dating, it is found that rocks of the same ages are found across the different continents. Like the Brazil coast matches the rocks along the Western African coast, and the marine deposits along the coastline of South America and Africa are of the same ages. Now, another one is tillite deposit, that is glacial deposits. The glacial deposits are also found in the Gondwana rock system. So, this is also questionable that the continents have moved from different position to their current position because the atmosphere in the Gondwana system is not such that there will be light deposit form. Another one is placer deposit, that the gold bearing rocks of the Brazil have the same structure as the Africa. Distribution of fossils like Glossopteris fern, Lemurias, Mesosaurus across the different regions where they are not endemic to. So this is also one of the evidence of continental shift. Paleomagnetic curves, that is These are the modern evidences, paleomagnetic curves. That is a study of the past magnetism of Earth. Gives evidences about the continental drift also. Now tell me in the comment section other evidences about the continental drift theory if you know any. Now moving on to the next. Next one is convectional current theory. As I told you that scientists are not convinced by the that polar fleeing forces and tidal forces are sufficient to move this continent. So in wake of that, convectional current theory was put forward by Arthur Holmes in 1930s, which states that in the asthenosphere, due to the presence of radioactive elements, there are convectional currents which are generated. Like this is the crust, this is asthenosphere, and this is how the magma moves in the same direction. The continent also moves. These are the convectional currents in the mental part. Now, later in 1962, the sea floor spreading given by Harry Hash, Harry Hash, which explains the formation of ocean floor and mechanism for the drifting of continents. It states that slab pull mechanism. It is based on slab pull mechanism, such that these are the this is ocean, these are land masses, and here these convectional current are operating like this, and magma is outpouring here and the ridges are there. So along the ridges on the both side the rocks are found of same ages, and the rock is newer near the ridge, and rock is being getting older as it moves away from the oceanic ridges. So this supports that the crust is being created at this divergent boundaries in the ocean floor, and it is being destroyed at the convergent boundaries. And finally comes the most prominent theory that explains the it's a plate tectonic theory given in 1967 by Wilson and Morgan. Now it states that lithosphere, that is crust and uppermost solid mantle, is floating on the asthenosphere, that is semi-solid upper mantle. Now it states that this lithosphere is divided into several crustal blocks which are known as tectonic plates, and due to their movement the earth is the current configuration of continents is there, and at the plate boundaries the formation and destruction of the crust is happening, and various activities like earthquake and volcanism are being explained because of this. Now these uh, tectonic plates, these can be oceanic and continental, oceanic or continental, and their interaction can be of different type like divergent and convergent. So divergent boundary can be of two types, that is ocean divergence, here forms the mid oceanic ridges. Second one is continent divergence, due to which fault lines like Great African fault lines are formed. Now coming to the convergent boundaries. So convergent boundaries can be ocean convergence. Here heavier plate subduction the lighter plate. So here the trenches are formed. ocean convergence. Trenches are. Second one is ocean and continent convergence. Here the oceanic plate subducts. This is the oceanic plate subducts under the continental and formation of fold mountains like Rockies and Andes are formed. Next one is continent-continent convergence, in which they are locked. And here volcanism is absent. Like this example of this is collision of Indo-Australian plate with Eurasian plate. There is also one type of interaction which is transform boundaries, in which convergence and divergence does not take place, but these plates slide past by each other. Here earthquakes take place. Now the limitations of this plate tectonic theory is that it explains the features of the earth which are located at the plate boundaries, but it does not explains the features that are not at the plate boundaries, that is interior of the earth. And the present configuration of features like Appalachian Mountain, Ural, Great Dividing Range, Drakensberg, so these cannot be explained by this plate tectonic theory. So this is all about this first part of video. We will meet in the next video. Mention your suggestions in the comment section and subscribe and share the channel.